guys, welcome to Outage of the Month. I came across something interesting today, and it's actually very relevant, and I don't know how many of you are aware of the concept of statistical significance and p-values. It's a fairly simple concept in statistics. It's the concept that you can test your null hypothesis. So say, for example, my null hypothesis is that if I smack my arm on this table, it's not going to hurt, right? And so I smack, like, does that hurt? I don't know, maybe it hurts. I'll do it again, and 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 I'll do it. And the concept is that I can reject my null hypothesis and say that it's not true that it doesn't hurt, that actually if I smack my arm on the table it does hurt if it happens at least 80% of the time. No, 85. How much is it? If it happens, oh my god, 1, 3. If it happens at least 80% of the time. So if my arm hurts once in 20 times, then I can still accept my null hypothesis, and if it doesn't, I have to reject the null hypothesis. It's a fairly simple setting, right? And I suppose I don't really want to discuss the whole abuse of p-values or abuse of statistics in trying to figure out what's happening. What I want to discuss is how this abuse of statistics highlights a decrease in quality evidence and a decrease in quality experiments, right? If you think about the olden days, well, I wasn't born then, but you know the classical experiments, the elegant experiments where the evidence doesn't need statistics. It doesn't need p-values. Why? Because it's not merely quantitative information with no context of what you might expect to happen, why you might expect it to happen, what might be going on. And so it's just mountains and mountains of data with no particular context that rely on mere correlations made significant or not by whether they have a certain p-value, which only goes to show you that there may or may not be something of interest in that particular area. So you might say, oh, that's significant. I have absolutely no idea why, but it's a hint. And that means that you don't have enough knowledge to figure out what might be going on. The data and the evidence only serves to form this knowledge. And if the evidence is not evident, then it's not evidence. So when you have this convoluted statistics and convoluted interpretations, it doesn't serve the purpose of getting knowledge. And another point about the convoluted stuff is that speaking of correlation, so what outrages me this outrage of the month is that we have found ways to get so much more data and to do so much more statistics, and yet the knowledge density of each new finding is so much lower than it used to be. You have mountains of data, mountains of statistics, mountains of data display and graphs and various manipulations. You have the statistics that are supposed to be robust, you have significances, everything is happening, everything looks so good on paper, and yet every conclusion is something along the lines of, this is not, we don't really know why, we don't really know how, we can't really explain this by that, we need to do more work about this, and it decreases the confidence, because really, you don't want correlations. You want causations, and that is given by a solid framework of a solid theory, of a solid something. You know what you're doing. You know 90% of what you're doing, and you're going to find out 10%. Not know 10% of what you're doing and try to find out 90%. It's not going to work. That knowledge does not exist in those statistics. Statistics is just a method of getting that evidence to be evident from stuff that you already know enough of to make sense of. There is no knowledge that is going to spontaneously come out of statistics. Statistics can only be used as a tool, and knowledge can only come out of an appreciation for the greater context and an appreciation for designing experiments so that you know that the data that you get will mean something, regardless of what the data is. You know you will find something out one way or another. I will find out whether this hurts or not. And I don't need to do statistics on it because I only need to do it once to know that it hurts or that it doesn't. Because I know everything about this experiment except whether it hurts. I don't need to do it a million times and then still be like, I don't know, but sometimes it does and sometimes it doesn't. You know, it's simple.